Hello students, welcome to the class. Good evening. Audio visual is clear.
Yes, sir.
Yes, sir.
Okay. Okay. Last Saturday we discussed about the cheese manufacturing process and each and every steps with details. Cheese manufacturing steps. Now the other fermented milk products we are going to discuss in this class. Other fermented milk products. We already discussed yogurt and cheese. Day number one, we discussed yogurt manufacturing as well as cheese. These two are the proper substance that produce after the fermentation of milk. And other fermented milk products like what are the other fermented milk products? We have acidophilus milk, buttermilk, acidophilus milk, kefir, and Koumis. Buttermilk, acidophilus milk, kefir, and Koumis. These are other four fermented milk products which raw material is the milk. Clear? Now we going to start one by one. Start with manufacturing process of buttermilk. Manufacturing process of buttermilk. ফ্লেভারটা একটু ডিফারেন্ট হবে process changes buttermilk can be of two types. One is traditional buttermilk, and other is cultured buttermilk. Cultured buttermilk. Cultured buttermilk produced in the industry scale and also called chach. Also called chach. Clear? So two types of buttermilk, traditional and the cultured buttermilk that we have consumed nowadays. That is industrial scale produced cultured buttermilk, or the Hindi term is chach. Clear? So traditional buttermilk means we know that the butter produced from the cream, when cream is churned, then butter is produced. Yes or no? When the milk cream is churned means stirred continuously, stirred. That time the butter is produced. Stirred or shake. That time butter is produced. So after butter production, the remaining fluid of the cream is called buttermilk, and that going to be consumed, and it is the traditional way, traditional buttermilk, not going to be ferment. It is a traditional buttermilk. So buttermilk, traditional buttermilk is when cream is converted into the butter after the churning, that is stirring or shaking. The remaining fluid is called buttermilk, and this remaining fluid contains good amount of phospholipid, which is a emulsifier. This buttermilk contains good amount of phospholipid, which is an emulsifier. So we can use the this buttermilk in the other purpose also, as well as we can consume this traditional buttermilk. This can also consume. But nowadays, the buttermilk is produced after the fermentation process. Nowadays, in industry scale, the buttermilk is produced after the fermentation process, and that's why it is called cultured buttermilk. That means after the fermentation, the buttermilk is obtained. Clear? It is the traditional buttermilk. Just we got from the raw materials after the butter formation, the remaining fluid. Done. So cultured buttermilk is produced after fermentation. And what is the raw material of the cultured buttermilk is not the butter. The term is a misnomer here. Cultured buttermilk not started with the butter. It started with just the raw materials, that is milk, raw milk. And it is going to be converted into the buttermilk, that buttery taste after the fermentation. And that's for use a special starter culture. Clear? So the cultured buttermilk produced after fermentation, and the raw material is not the butter. Raw material is just milk, raw milk, whole milk, not the butter. But originally, traditionally, the buttermilk is produced after the butter formation. That's why the name is given buttermilk. But nowadays, not butter. Do not use any butter for the raw milk for the formation of buttermilk. It is just milk is used. But after the fermentation, the taste is like buttery. That's why it is called buttermilk. Clear? Introduction is clear. Buttermilk introduction is clear. Now we are going to introduce the steps involved in the manufacturing of buttermilk. Cultured buttermilk. Cultured buttermilk production. Manufacturing process of cultured buttermilk. Cultured buttermilk. And the step number one is standardization of liquid milk, which is the raw material here. Standardization of liquid milk. For the cultured buttermilk process, we need to use low fat or whole, sometime non-fat or sometime whole milk also be used. For standardization process, some amount of milk solid also we are added. Non-fat milk solid are added frequently. It's an optional step, do not absolutely need it. Optional. Point number two. Majority time it is used non-fat solids. Third is absolutely needed for this taste. Stabilizer and other ingredient like citrate and small quantity of salt, table salt is used. The key component here is the citrate. The key component here is the citrate. So we are taking either non-fat or low fat or sometimes whole milk can be used. Milk solid can be increased. It's an optional step, but third point is important. Citrate is going to be added into the raw milk. And what is the purpose of adding citrate? What is the role of the citrate? We're going to discover at the end why citrate is so much important for the buttermilk taste, flavor, texture. Clear? So the manufacturing process number one, step number one is the standardization. First take the raw material and standardize. So step one done. After that, the process is homogenization. Homogenization means all things should be mixed thoroughly. Mix all components and form buttermilk mix. Buttermilk mix. After mixing process. Step number three, heat treatment. Now the buttermilk mix is heated.
Sir,
uh,
homogenization, you have written mix all components and buttermilk mix. Sir, that point I didn't understand.
Mix all the components means you taken the whole milk or non-fat or low fat, whatever kind of milk you use. Then you use the non-fat solids. It's an optional step, but sometime added, as well as the citrate and the salt. You are used in the mixing process. So it needs to properly mix. Other than that, no homogenization is done. That's why mixing, properly mixing, and it makes the buttermilk mix. That means it's going to be ferment and produce buttermilk. That's why it is called buttermilk mix.
So means every drop of the milk contains the same amount of
Same
nutrients.
amount of nutrients, same amount of citrate, same amount of salt. That's why it is the proper mixing needed.
Okay, sir.
And it is the process called homogenization. Homogenization means every drop of the milk contains same nutrient. Correct. And it is
Okay.
called buttermilk mix because after that the fermentation it produces the buttermilk texture. That buttermilk. That's why it is called buttermilk mix. That's just like we are going used into the market and search for idli mix. That means after the ferment it produces the idli or the dosa mix. Right, like that it is produced buttermilk mix. Means after ferment it produces buttermilk. That's why it is called buttermilk mix. So homogenization is the important step. Other than that, the proper mixing could not achieve. Clear? And after that, the step three is the heat treatment. Third step is heat treatment, and the heat used, temperature used is 85 to 9. Yes, 85 to 88 degrees centigrade for 30 minutes. And this temperature at time also used in the case of yogurt manufacturing. Remember that. Check previously yogurt manufacturing step we are using the same heat and the same time duration. That means above the pasteurization temperature. Here also we are using above pasteurization temperature, and the simple function is that spoilage causing organism, heat resistant organism, and other disease causing organisms all are going to be killed after the pasteurization. Above the pasteurization temperature used, and why it is used as a simple heat resistant microbes is being killed, as well as spoilage causing organism and disease causing organism also eliminated. That's why we are using the heat treatment above the pasteurization temperature. Normal pasteurization temperature is 72 degrees centigrade, but here we use plus 10 plus 12 degree temperature uh, from the pasteurization temperature. That means 85, 88 degrees. Pasteurization also kills microbes, spoilage causing, disease causing, but these heat resistant microbes survived in pasteurized temperature. But we need to eliminate that microbes also during the manufacturing process of yogurt, like in buttermilk. That's why we are using above, just above the pasteurized temperature. Normally 72 degrees centigrade are used in the pasteurized temperature, but here we use plus 10, 12 degrees centigrade. That means 85 and 88, and which is sufficient to kill heat resistant microbes. Clear?
Yes, sir.
And next step, before the starter culture addition, now the whole mix is above 80-85 degrees centigrade, so we could not add at that point starter culture, so we need to cool at room temperature, then we are going to add starter culture. So next step is cooling. This cooling is needed because at that point if starter culture is added, all starter culture being killed, all starter culture containing microbes contain microbes are being killed. So no, cannot use at that point after the heat treatment. It need to be cooled at the room temperature. After that, we are using starter culture for buttermilk. So number four step is being cooling. The mix is then cooled to 22 to 25 degrees centigrade, which is the ideal temperature for growth of starter culture. So number four steps is done. Number five, addition of starter culture. Addition of buttermilk starter culture. Addition of buttermilk starter culture. The starter culture contains mesophilic bacteria. That's why we are use temperature, cooling temperature at 20 to 25 degrees centigrade, because mesophilic bacteria love to grow that period of temperature. That means 20 to 30 degrees centigrade. That between. If we use the thermophilic bacteria, sometimes it is used in the cheese manufacturing process. That time we are use the high temperature. Okay, so here the buttermilk starter culture is mesophilic bacteria. Mesophilic bacteria that love to grow that temperature. And starter culture for buttermilk is a combination of acid producing bacteria, acid producing bacteria, as well as the flavor producing bacteria. So two bacteria combine and make the starter culture for the buttermilk, and the ratio is 5 is to 1. Acid producing bacteria taken in high quantity, high concentration, and the flavor producing bacteria is in low concentration, but should be added flavor producing bacteria because buttermilk has the strong flavor of butter that cannot make individual by the lactobacillus. So it needs some other lab which is basically produce that flavor, buttery flavor. Clear? 5 is to 1 ratio. 5 is to 1 ratio. So acid producing bacteria can be used Lactobacillus lactis, also Lactobacillus cremoris. Flavor producing bacteria, we can use Leuconostoc cremoris, or we can use Leuconostoc lactis. Any one from the list of two. Lactobacillus lactis, Lactobacillus cremoris, Leuconostoc for the flavor producing bacteria segment, Leuconostoc cremoris or Leuconostoc lactis, and added in the 5 is to 1 ratio. So they are called acid producing bacteria because they are solely homofermentative bacteria. That's why it produces only lactic acid, yes or no? Why they are called lactic acid bacteria, acid producing bacteria? Why they are called acid producing bacteria? Because they are homofermentative in nature, homofermentative in nature, and produce only lactate, lactic acid. Clear? But the flavor producing bacteria is basically they are heterofermentative and they can make different product other than lactic acid. Clear? That's why it is called heterofermentative bacteria. Heterofermentative bacteria is the character to produce lactic acid as well as other product, other flavor in enhancing product. That's why we are used in the combination. Flavor as well as lactic acid means acid producing bacteria combination. Yes, we need more acidity. That's why the quantity concentration acid producing bacteria is relatively high, and the flavor needs less because it's an organoleptic property. It needs less quantity. Less quantity is helpful to make the flavor and texture. That's why we are using in small quantity, but it is needed for the buttermilk production. So question can become why both types of bacteria used during the manufacturing of buttermilk. Question: during buttermilk production, both acid producing and flavor producing bacteria are used. Why? Important question. Now you can easily discuss why. Because we need the flavor, we need as well as acid. That's why we are using both kind of bacteria in a starter culture. Clear? Starter culture clear. Step number 5 clear. Understood everybody? Online
Yes,
student.
Yes, sir.
Okay.
yes, sir.
Step number 6. Step number 6. After that, the starter culture addition, you need to be incubated for some time because fermentation is going on. So step number 6, incubation. Now the mix is incubated at 20 to 22 degrees centigrade temperature because it is optimal for the mesophilic bacteria, those bacteria to grow for at least 12 to 16 hours to complete the fermentation process. At least 12 to 16 hours. Step number 6 is done, followed by after the fermentation, need further cooling, that means refrigeration and agitate. Cooling and agitate. Agitate means to mix the after fermentation all things are produced, so we need further mixing. That's why agitation is given. Product is cooled at 2 to 4 degrees centigrade temperature, that means normal refrigeration. Agitation oftenly done to break the coagulum, oftenly done to break the clump or coagulum. Same thing. At that stage, some amount of salt, some spices, roasted spices can be used. Like that in India, we are using jeera for taste. Chach can be produced by using some spices. Spices and some butter granules. Extra butter granules can be added. Hmm. Butter granules can be added. Optional. It depends on the geographical area because India needs peoples are needed more spicy. That's why they use spices, some butter granules, and followed by packaging. Followed by packaging. Manufacturing process done. Buttermilk. So clearly for the buttery texture, buttery flavor, we are using special type of starter culture mix and we are using combination. and they create that buttery aroma flavor into the product, final product, buttermilk. Yes, yes, we are coming to that. So next question is why the butter flavor is derived. How the butter flavor or aroma is derived? Because these bacteria are going to ferment also the citric acid which is given earlier during the standardization step. And this citric acid after fermentation produce, check the citric acid fermentation. So question is why buttery flavor? This is another potential question for final exam. Why question or how does buttery aroma created buttery flavor produced in buttermilk? Because we are using the raw material milk, we do not use traditionally like butter. So how does the buttery flavor is created? Buttery flavor is created by the citric acid which is used during the standardization step, and this citric acid is fermented by the these two bacteria. Citric acid mainly fermented by the heterofermentative bacteria, but still homofermentative bacteria also can be used. So citric acid fermentation, after citric acid fermentation produce oxaloacetate. Oxaloacetate, short name is OAA. Oxaloacetic acid. From oxaloacetic acid, pyruvate is formed. Pyruvate is formed, and this pyruvate can produce two products. One alpha acetolactate, another acetaldehyde. This acetaldehyde produce ultimately diacetyl, and alpha acetolactate convert into acetoin, and acetoin convert into 2,3-butanediol. 2,3-butanediol. And these two products, one is diacetyl, other is 2,3-butanediol. These two products provides the buttery flavor. These two products give buttery flavor, texture, aroma, all kind of organoleptic properties. So we are using simple milk to make buttery flavor like buttermilk. And how does it produce? It produces from the citric acid. That's why citric acid is so much important to add during the time of standardization. And another question is, this can be another good question. Why citric acid is added during buttermilk production? During buttermilk production, because at the time after the fermentation, this citric acid convert into 2,3-butanediol and diacetyl. This gives the buttery flavor. Buttermilk manufacturing process complete. Any question from that buttermilk manufacturing process? Otherwise, we
No.
jump to next fermented milk product, acidophilus milk. Acidophilus milk. Clear? Monomoy? Okay. Acidophilus milk. Next topic. Next manufacturing process. This is called probiotic milk. It is a probiotic milk. So clearly, probiotics, that means probiotic microorganisms are added into the starter culture. Yes or no? So here we are using probiotic microbes, lactobacillus. Lactobacillus is a good probiotics and the special strain, starter culture. Lactobacillus acidophilus. The name of the bacteria is Lactobacillus, as it is a component of Acidophilus milk. The species name is Acidophilus. Lactobacillus acidophilus. It is a homofermentative or a heterofermentative bacteria. Homofermentative bacteria, that means clearly produce acid and make the taste of the milk is sour. So it is acidophilus means it can produce huge quantity of acid. So sometimes the product is after the product fermented product is heavily sour. So sometimes we need some amount of sweet or sugar to add and make sweet acidophilus milk, because the normal fermented acidophilus milk is highly sour, it cannot be palatable. Sometimes sugar can be added, sugar is used, so make uh, sweet acidophilus milk. The point is traditional acidophilus milk contain high lactic acid, and it is too sour to consume. So that is why sugar is added, small amount of sugar, which balance the taste of sour and sweet. Small amount of sugar is added and produce sweet acidophilus milk. So production of sweet acidophilus milk, production of acidophilus milk, basically same. Please do not confuse if the question is written. So how does it you produce sweet acidophilus milk? The steps is same. Only sugar is added during the yeah, standardization step, because the acidophilus milk is highly sour. That's why some amount of sugar is added to balance the taste. So that time it is called sweet acidophilus milk. Yes. কনজিউম করা যাবে বাট ডিফিকাল্ট, সবাই পারবে না, সবার কাছে প্যালেটেবল হবে না। বাট আমরা তো মাস টার্গেটে পৌঁছতে চাই, হ্যাঁ, মানে একটা ইন্ডাস্ট্রিয়াল প্রোডাক্ট প্রডিউস হচ্ছে বিকজ অফ মাস টার্গেটের জন্য। তো স্মল টার্গেট তো নয় অবভিয়াসলি, because it is used in the economic purpose ultimately. So sweet acidophilus milk can be used in the all people. Manufacturing steps. And Indian people love sweet. Indian people are crazy about the sweet sugar. So some sugar is must added. That's why diabetes rate is high. Diabetes high, insulin problem maximum here. So number one, simply standardization of milk. In the standardization step, we can use low fat or whole milk, and small quantity of sugar added in sweet acidophilus milk production. And properly mixed. Point number two, it should be heated. Same like the buttermilk, heated at above pasteurization temperature. '85 to 90 degrees centigrade used, and the need for above pasteurization is same simple logic as previous. Number three, inoculation of starter culture. Inoculation of starter culture, which is the special bacteria here, Lactobacillus acidophilus. Only one single kind of bacteria is used, Lactobacillus acidophilus. Used in 2 to 5% concentration. What will be the next step? The cool down is done. After heated, cool down, cooling. Starter culture inoculate done. Incubate করতে হবে because it needs some time for fermentation. Allow the fermentation. So next step is incubation. Step number 4, incubation up to 24 hours. Or check the lactic acid quantity, because Lactobacillus acidophilus produce huge quantity of lactic acid. So we need to regulate the lactic acid production. That time when the lactic acid produced reach to the 1%, 1% of the lactic acid is produced into the mix, the reaction is going to be stopped. Clear? So just you need to incubate for time or check the lactic acid quantity, followed by cooling to 5 degrees centigrade, and that cooling arrests the fermentation process. That temperature arrests fermentation process because lactobacillus could not grow at below 10 degrees centigrade. It is mesophilic bacteria, so it needs a temperature 25 to 30. And we are going to now use cooling at 5 degree. That means refrigeration. So arrest the fermentation. So no lactic acid further produced, accumulate. Clear? And simple after that package and distribute packaging. So in acidophilus milk, two steps are important. What starter culture you are going to use? It is importantly Lactobacillus acidophilus. And the second important step is the incubation time. It is very important. Other than that, the more lactic acid is built up and the product is more sour, so cannot be consumed. হ্যাঁ সুইটটা তো অলরেডি দেওয়াই আছে তোমার ওই স্ট্যান্ডার্ডাইজেশন এই যে স্মল কোয়ান্টিটি অফ সুগার ইজ অ্যাডেড, so already addition done, so do not need further. So we need to check the lactic acid quantity because lactic acid acidophilus produce huge quantity of lactic acid and to make the product more sour, which is not palatable at all. That's why lactic acid concentration is checked thoroughly. And when it reaches to the 1% level, the fermentation should be stopped then. And how does the fermentation stop? By cool down, refrigerate, 5 degree, 4 degree centigrade. Because that temperature fermentation is stopped, no bacteria is grown. Lactobacillus cannot grow at that temperature. Process clear. Acidophilus milk
Yes, sir.
production. Next, fermented product, kefir. Another popular fermented milk, kefir is most widely consumed. Consumed cultured dairy product all over the world. And kefir is fermented liquid milk. Fermented liquid milk. So it is remain in the liquid state. After fermentation, it remains in liquid state, liquid milk. Kefir is different from other dairy product manufacturing process. in some point. That means we discuss yogurt, cheese, and buttermilk. Clear? Buttermilk and acidophilus milk. And these all manufacturing steps and the kefir manufacturing steps are slightly different. And what is the unique about the kefir manufacturing steps? Number one, process. Here, kefir grain are used as a starter culture. Kefir grain, which is actually a solidified mass. Kefir grain is solidifying mass, and it looks like a mushroom or cauliflower. Here the starter culture is actually solidifying mass. But in previous case, all the starter cultures is remain in the liquid, yes or no? But the kefir manufacturing step, the starter culture uses itself solidifying mass, and this mass contain millions of bacteria and other microbes. Clear? And it's a shape like a cauliflower. So what is kefir grain? What is kefir grain, which is the differentiate process from other manufacturing step? Kefir grain is the of mass of bacteria, yeast, and different kinds of metabolic product of this bacteria and yeast. Different kinds of metabolic products like proteins, polysaccharides, lipids, etc. So this is important question. What is kefir grain? Kefir grain actually is a starter culture which is a solidified mass and that contain bacteria, yeast and their metabolic products which is clumped together and form cauliflower shape. Kefir grain clear. Kefir grain clear. Kefir grain
Yes,
point clear. So clearly many bacteria and yeast are there. Some examples are Lactobacillus kefiri, Lactobacillus kefiri, Lactobacillus aceti, and third, sorry, Acetobacter aceti, Lactobacillus kefirino- kefirinofaciens, Lactobacillus kefirinofaciens, Kefirano, RAN, Kefiranofaciens. So these are some bacteria found in the kefir grain. Lactobacillus kefiri, Lactobacillus kefirinofaciens, and Acidobacter aceti. Some yeast are also present, and examples are Saccharomyces kefiri, Saccharomyces kefiri, and Candida kefiri. Candida kefiri. Here, most of the students are going to confuse how does it work. It's a solidifying mass. So solidifying mass, how it works? Check the manufacturing step. So first unique point of kefir manufacturing step here the starter culture is in the solid state. first unique point. And the second unique point here, yeast are also used. Check that. But previous manufacturing step, no yeast are used, only lab are used, either homofermentative or heterofermentative or combination. But here, yeast, that means fungus, also used. If yeast are used, then yeast produced after the fermentation, which product? After fermentation, yeast produce which product? Lactic acid or ethanol? Ethanol produced. That means after the kefir manufacturing steps, we are also tested ethanol, also found ethanol. So which make another important flavor producing or flavor enhancing uh, outcome. Right? Clear? So this is the another unique point in the manufacturing step. So point number two. Point number two, unique point from other dairy product. Here yeast are present, so small quantity of ethanol also produced that make the flavor more enhanced in the kefir, and flavor is also different from other fermented product. Yes or no? Because other fermented product contain only lactic acid bacteria containing products, outcome products, but here combination of lactic acid bacteria products as well as the yeast product and make a unique flavor. So here kefir kefir grain contain yeast that produce ethanol, small quantity of ethanol, which enhance the further or which give unique taste, which give unique taste. That's why kefir is different. Third point, the starter culture used here is also can recycle or reuse because it is a solidifying mass. We can easily stain and remove the kefir grain after the fermentation process. So we can reuse the starter culture here. So point number three. Kefir grain after fermentation can be removed and used in another batch of fermentation. Can be removed and used in another batch of fermentation. So like that way, one kefir grain can be used in 9 to 10 batch of fermentation easily. So we can reuse that. But in the previous manufacturing step, can we reuse the starter culture? Can we reuse the starter culture? Yes or no?
No, sir.
No. But here it can easily be used. So 3 points that make the unique about the kefir production. It's an important question. Another important question. Why kefir is so different from other manufactured milk products? Clear? Understood? Everybody, online students, manufacturing steps.
Sir, but one time when the kefir grain is used, that times the microbes present in it is already utilized. Then the
No,
second
not
time,
all microbes are utilized. Microbes are stuck in a mass. Microbes are stuck in a mass. So microbes are utilize the nutrient from the milk and convert the milk into the lactic acid or other product. But microbes are not utilized. Microbes is still stuck in the kefir grain.
Okay, sir.
But some, yes, some microbes is dissolved, but clearly it contains millions of microbes. So not microbes, not all microbes are getting dissolved into the kefir, kefir after the product. So clearly
Okay,
we can
sir.
reuse. But reusable time also 9 to 10 batch. After that, microbes are not so much useful, or that fermented products is not produced. So further, another round of kefir grain should be produced and used for that. So 9 to 10 batch is enough. 9 to 10 batch can easily be used. After that, it will be discarded. Clear? Clear my point?
Yes.
Microbes is still stuck after the production and can be reused. Okay, kefir manufacturing process. Kefir manufacturing process start with standardization as usual, standardization of milk, followed by heat treatment, then cooling, and here also above pasteurization as previous step. Temperature is used, followed by cooling, then spreading the kefir grain, spreading the kefir grain at the bottom of the container as it is a solid. So it first spread into the container, then the raw milk is added. Bottom of container. And then the pasteurized milk poured. Pasteurized milk. Allow the fermentation incubation time. And here the incubation time, fermentation time 18 to 24 hours at 20 to 22 degrees centigrade temperature, mesophilic strain. And after the fermentation process, how can you know? How did you know that the fermentation is done? Because after that fermentation, kefir grains are floated. It is remaining the submerged into the mill at the time of fermentation, but after fermentation, the kefir grains are floated. So that is the indication point. After fermentation, this is the indication point that fermentation is already done. At that time, kefir grains are float. Now retrieving the kefir grain by simple staining, retrieve kefir grain and store for another purpose, another culture, and store for another round of fermentation, which is unique here, another batch of fermentation. After retrieving, the liquid milk is called kefir. The liquid fermented milk is called kefir. But this kefir is the mother kefir. highly concentrated, highly concentrated, and then the drinkable kefir is formed, produced. So drinkable kefir is produced. Just dilute this mother kefir 8 to 10 times by diluted 8 to 10 times with pasteurized milk. Produced drinkable kefir, stored and packaged, and ready for distribution. Kefir productions. Kefir manufacturing steps. Unique about the kefir grains. Reused. হ্যাঁ high concentration ওটাকে আবার আমরা drinkable kefir এ convert করি by means of diluted 8 to 10 times with the raw milk, pasteurized raw milk. Clear kefir production step, important, unique. Is it clear to all?
Yes.
Kefir,
Yes, sir.
kefir manufacturing. Okay. Last, milk fermentation product. Koumis. খুব একটা চলে না। Outside এ heavily চলে and most usable মানে drinkable product, milk product. Nutritional value is increased. Taste unique. Next product, Koumis. Here the raw material is unique. That's why the texture flavor also unique at the end. The raw materials here used is the milk, but the milk is derived from mare's milk. না এটা তো বাফেলো হবে mare's milk means horse female adult horse is called mare female produced colonies so female horse is called mare adult female horse. So unique point here is the raw material that is used. Raw material is derived from the mare's milk. That milk, after the product, after the fermented, texture is different and it given the separate name. Regionally is used in the Russia, started in Russia. So that continent, your Koumis is another popular drink. So materials is different and also the starter culture. And the overall steps is same. Starter culture. Another popular drinkable product. milk waste. Starter culture here used Lactobacillus bulgaricus, Lactobacillus acidophilus, Flugeromyces species. Clear? Manufacturing step, same, just raw material. Standardization process, the collecting raw material is different. Number one, standardization of fresh mare's milk. That is important. Followed by same thing, heat treatment, cooling, addition of Koumis starter culture,
Sir, heat treatment above pasteurization temperature.
same. 85 to 90, same. Addition of Koumis starter culture, incubation, mesophilic bacteria need 25 to 26 degrees centigrade, 2 to 4 hours. Do not need more times here. Just 2 to 4 hours needed. After that, bottling and resting for 30 to 60 minutes. Next is refrigerated cooling at 4 to 6 degrees centigrade. And number last stage, store and package. Package and store. It is also in the liquid state. Remain in liquid state. So first two, yogurt and cheese. Yogurt is semi-solid, cheese is completely solid, and rest of the other milk products, fermented milk products, are all a liquid state. Acidophilus, buttermilk, Koumis, and Kefir. All are liquid, but fermented. Unit 2 almost end. I need another class about milk food product spoilage. And with that, unit 2 also being completed. In next class, we discuss about milk product spoilage. Some spoilage, what are the microbes are involved in the spoilage and how does the spoilage occur, some name of the spoilage, etc. Milk product spoilage. So next class we discussed about milk product spoilage and unit 2 is going to complete with that. So পুজোর আগে complete করে দেবো unit 2 and after পুজো it going to be exam about unit 2. Clear? Any question
No,
from
sir.
today's class? So class is being ended.